Hello guys, today we're going to be learning about graphing linear equations. So that includes, let's look out right here. So first of all, we're going to graph down slope, intercept, form, and we're going to do, inequalities, linear inequalities. We're gonna do, let's see. We're gonna learn how to find the slope. And we're gonna learn how to find the y and x intercept. Okay, so that's all of these four listed out items are what we're going to be learning today and really what we're going to focus on. So first, let's start off with x and y. So let's click on this feature right here. Okay. So first we're gonna focus on what slope and y-intercept is. So slope is, let's just take any line. So suppose any line right here. There's different kinds of slopes. There's negative slopes, there's positive slopes, and there's a zero slope, and there's an undefined slope. Now, right here, this line has a negative slope since it's going down. So now let's take a look at what a positive slope would look like. Yup, you guys guessed it. Something like this. Now, this one is a positive slope, and this one is a negative slope. An undefined slope would be something like this. A vertical line. So you wouldn't necessarily call this a zero slope. I mean, you couldn't. This would be called an undefined slope or undefined line. And right here would be a line with a slope of 0, a line which is horizontal. So, yep, those are like the basic standards of what you need to know for like the different types of slopes. Now, let's take a look at equations. Now, we're going to be learning about slope intercepts first. What excuse me. What exactly is slope and what is intercept? So, first let's learn about slope. I shouldn't really get to the equations yet. My bad. Okay. So right here is a coordinate. Now I think you guys may know this, but right here is x, and right here is y. Um, so this entire line is the x-axis, and this line right here is the y-axis. And to number this, you would go something like 1, 2, 3, 4, 5, 6, 7, 8, and so on. And to number the x-axis, you would go like 1, 2, 3, 4, 5, and so on. Now, on this side of the x-axis, you would go -1, -2, -3, and so on. And same thing for this part of y. Now right here is 0, 0. That is the coordinate of this point right here. So the most basic linear line I can think of would be a line with a slope of 1 and a y-intercept of 0, which would be right here. Now first let's learn about slope and how we can find out slope. So let's make a line. So right here we have a really simple line. Now don't be confused by this. This isn't a line segment. This is like a line, so it's gonna go all the way like that. It goes up to infinity. So right here we have a line with a y-intercept of 0. Now what exactly is y-intercept? So y-intercept is like the coordinate where the line touches the y-axis. So right now it's touching y at 0. Now if let's say I had a line like this, would the y-intercept still be 0? Think about it. Give yourself a second and answer this question. Okay, so this line right here would not have a y-intercept of 0 because it dissects the y-axis right over here. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be -8. So the y-intercept is negative. Oh, my bad. Okay. So the y-intercept is going to be -8. And that's 0, so we don't really have to write that down. So we're making an equation right here. Now first, so yeah, that's the y-intercept. Now, now let's focus more on the slope. So what exactly is the slope? So here's how I think of it. It's rise upon run. Think of it like that. And this will help you remember how to find out slope. So let's think of it this way. I make a line right here. Now, what exactly is rise upon run? So think of it this way. Whenever you're representing the slope of a line, you're gonna do y upon x. Yeah, just like that. So y would be like it's this vertical axis right here, and x is the horizontal axis. So that's why it's rise upon run. So run is like x and rise is y. So now let's see how much does this line rise. So first let's pick 2 points. 2 points on this line. Let's pick this point right here. And let's pick this point right here. So let's mark them. Now, uh, it's going up by 1, so that's a rise of 1. And so when it gets there, that's a rise of 1. It it runs another 1, so 1. Now that simplified is 1. So the slope is 1 upon 1 or 1. So there's your slope for this equation. And this equation too. And same thing for this. So you would represent so that's your slope, and this is your y-intercept. So it's really simple. Now, let's focus on the main part, equations, and how we can graph them, and how we can make equations from linear graphs. So we have y right here equals, so we're going to do y equals the slope. Well, the formula, let's think of the formula for this. Mx plus b. So this is the formula for slope-intercept form. So you're always going to write y equals, and then for m, what exactly is m? Let's think of this. What's m, guys? So m is the slope of a line. So in this case, m would be 1. So let's write, so when you're representing, don't mind me, when you're representing a slope of 1, a coefficient of 1 that comes before a variable, you simply just write the variable. So we're just gonna write x. You don't really need to write 1. Now, you could write 1x, but it doesn't really fit. And you're gonna write, well, in this case, it's minus. So never mind that. So b, let's talk about b. What exactly is b? It's the y-intercept of the line. Don't be confused. Don't think it's the x-intercept of the line. Now, I think you guys might know what the x-intercept of the line is. It's where the line dissects the x-axis. Anyways, let's focus on how to put this in the equation. Now, if it's negative, you're simply, in this case, the y-intercept is negative. So we're just gonna write um, -8 right here. Now, if this would have been +8, then we just would have wrote +8. Really simple. So this is basically how you graph a linear equation, linear line, in slope-intercept form. So, yeah. And same way, guys, now if we have this equation, let me just, small one. Now, we have this equation. How would we graph this? So first, we take the slope. There's nothing in front before x, so that's 1. Now, the slope of 1. Now the first thing we do is look at the y-intercept. Now that's -8. So you get down 1, 2, 3, 4, 5, 6, 7, 8 right there. So we're at -8 right now. And the slope is 1. So we're gonna have a rise of 1 and a run of 1. Rise of 1, run of 1. Rise of 1, run of 1. And so you have this line. It's really simple. So that's basically how you graph a linear equation in slope-intercept form. So let's get rid of all that. And now let's move on. Now let's focus on how to graph inequalities. Or maybe we should do that after finding out some other ways to find out the slope. So there's some other ways to find out the slope which are very interesting. So let's go right over. Okay. So let's make a line right now. Okay. So right here on this line, there's another way to find the slope. Now, you guys can tell the slope is 1, but we're going to find another way to do this. So, let's text box. Now, there's formulas for this. Now, one way is we could do y1 minus y2 upon x2 minus x1. So that's a formula right there. Okay. And so there's another way, which would be the Pythagoras Theorem. Now, this might be in geometry. This is in geometry. Oh, my bad. Here. Oh, sorry, y'all. Okay. So, am I spelling this right? So right here, let's learn about this part first. This might be a little more complex for you guys, especially if you're beginners. But let's learn this first. So what is a y1 minus y2? So let's oh sorry about that, guys. Y2 minus y1. Okay, yeah. Now, what is y2, what is y1, what is x2, and what is x1? So basically, you just pick 2 points on this line right here. So let's get a different color. Now I want to pick this point right here, and let's pick this point right here. Now we're gonna find out the coordinates of this point. Now, guys, remember this method is really useful when you want to find out the exact slope in like a decimal or something for a test. This is really handy. And there might be a lot of questions on this, like on a test, especially on SAT. So yeah, this is really important. Uh, so we're gonna find out the coordinates right here. So 1, 2, 3, 4, 5, 6. That's -6. So that's y. And oh, that comma was too big. So that's -6 and 3, 4, 5, 6. So 6, -6. Those are the coordinates for the first point. Now for the second point, basically we're just gonna go to forgot to add the -6. We're just gonna add 2. I already counted it, so it's gonna be -8 and -8. So these are our coordinates. Now, you can make any equation, the first equation and the second equation. Now, after making, so I'm gonna make the first equation first. Second, okay. Have them labeled. Now, let me open up a textbook right here. So, now let's use this method up. Now, so it says y2. Now, that means y of the second equation. So, think of it like this. The second equation is this one, and we're going to take y out of it. So, that's going to be -8. So, we're going to do -8. And then minus y1. So, y of the first equation, which would be -6. So, we're going to do minus 6. So, we need to simplify this part. So, minus minus, that makes plus. So, -8 plus 6. So, we have -2 for the first one, for the first part. Now, let's move on to the denominator. X2 minus x1. So, that means x of the second equation minus x of the first equation. So, we're going to do -8 plus -6, plus 6. So, yeah, we don't need to write that down. Just gonna move on. Good stuff. So, right here we have -2 upon -2. So, we just simplify. And our answer is 1. So, the slope of this line is 1. Now, this is one way. Another way is find out the slope of a line. Now we're going to learn about the Pythagoras Theorem. So, here's how this works. So, you can make a right triangle, and, well, you can, you have to find out the lengths of each side, and let me explain this. Okay, so right here we have line. Now we're gonna make a triangle. So that's one side. So another side. Out of those 2 points we picked. Now we want to find out the slope. How are we gonna do this? We find out what this equals 2. Now we find out what this equals 2. So the length is 2 and the width is 2. Now here's how we're gonna do this. So the formula for Pythagoras Theorem is a squared plus b squared equals c squared. So it's really simple. A and b can be any length of the triangle. So A is going to be the length and B is going to be the width. So we're going to square up A, which is 4. A square, which is going to be 4. So if A equals 2, A squared is going to be 4. And then plus, so we have 2 right here, that's B, and then B squared would be 4. Equals C squared, which is 8. So if C squared equals 8, we simply just we square up 8. Now, so for the answer is 8. We find the square root of 8 to remove that. So this is our answer, C. So that would be basically like the missing length. Yep. Okay. So now let's move on to the final and most important part. Oh well, this is like really common, so like a lot of tests and stuff like that. So let's take a line. Let's get a coordinate. Sorry about that. It's kind of glitchy. Okay, let's start working on this. Now, here's another way. This line's quite not right. Okay. So here's how we're gonna do this. So first, let's say we have a table. Let me see if there's a feature for a table. Yeah, let's just make one. Now this is the last way to find the slope of a line. So let's say this is x and this is y. Oh, my bad. Apologize for that. Anyways, let's put in numbers in here. So let's do 1, 2, 3, 4, 5, 6. Oh my god. 1. Yeah, let's do that. So here's how we're gonna solve this. The formula is delta y. So the difference. So delta is like the difference. So the difference in y. That's delta. So that's delta y upon delta x. So the change in y above the change in x. So first let's find out the change in y. It's going plus 1. It's really that simple. So plus 1, plus 1, plus 1. So that's like the difference we're seeing. So plus 1. And now, so that's the change in y, delta y. And right here, it's plus 1, same thing, plus 1. So really simple, 1 upon 1, which leaves us with the slope of 1. So this line is not correct. So we're just gonna trash them out. Oh, let's just, yeah. So a line which would fit that would be like a line with a slope of 1. Okay. So now let's move on to, let's see. Yeah, let's move on to inequalities. Graphing inequalities. So, this is like kind of the more complex part. With knowledge of what we just learned, this is gonna be kind of tricky, but yeah, it should be understandable. So let's think of it like this: we have an inequality. Y is my bad. Yeah, let's think of it like this. Y is less than or equals to x plus 7. Okay, let's think of it like this. So, this is our equation right here. Now, we have an coordinate right here. Right here, we're gonna graph this as y equals x plus 7, slope-intercept form. We're just gonna graph a simple line. So, slope would be 1 and intercept would be 7. 1, 2, 3, 4, 5, 6, 7. Now, okay, we're good. That's our simple little line. Now, when you're graphing inequalities, if it's like a greater or equals to or less or equals to, if it has a or equals to like to it, it's gonna be a solid line. Now, if it's only something like, let me type in something right here. Let me get a text box and do y is less than just that x was 3. Now, since it's less than and it doesn't have a or equals to, it's gonna be a dotted line. So so think of it like this: or equals to is solid, and no or equals to is a dotted line. Now let me give you an example of what a dotted line would look like. So it would look like, oh my god, something like this. Well, I'm not like the best at drawing lines, but it should be straight and it should look something like this. Or it could even be like, uh yeah, it could be represented in any way. So yeah, you guys got the idea. Now, um, let's just redo all this. Now, let's get to actually graphing an equation. So, let's there and let's make let's make an equation for this. So, y is less than or equals to x. Oh yeah, let's just do the same one we did last time. Oh, but my coordinates are different. One, two. Okay. Let's move to the good stuff. This is like the main part. So once we're done with graphing the slope-intercept form of this, remember it's a solid line. So we're gonna move on to the shading part. So whenever you're graphing an inequality, you're gonna put y. So after you're done with the graphing this line, you're gonna put y on the left hand side, or LHS, and you're gonna put like x, or like 2x plus or minus 3 or whatever on the right hand side, or RHS might be represented as a different way. So after doing that, you're gonna see if y is less than or equals to, is less than, or it says y is greater than. If it says y is greater than, then you're gonna shade above the line. So in this case, y is less than, so we're gonna shade below the line. So let me give you an example. We're basically just gonna shade under this line. So that would be anything and it just like keeps going. So all of this side, okay? All this side. None of this side, none of this side. So the other side, the like the upper side of the line, that's not going to be a solution. So a solution to this inequality, if it was graphed on the x and y axis, a solution to this inequality would be anything which is shaded right here. So it could even be something like miles away from like this point. So, but like anything on the bottom of a line. So that would be solution. Now, if it would have said y is greater than, or y is greater than or equals to x plus 3, we would have shaded above the line, and a solution would be anything above the line. Okay, guys, so I think we've covered all of our topics on graphing, linear inequalities, and this is really good preparation for your SAT exam. And yeah, because this is going to be really common on the SAT. So this is like a great studying tool. Okay, thank you. Don't forget to subscribe to my channel. Alright, bye.